or categories of formal design. Now, what is so important about formal design is these formal designs are the ones which will have to be adopted, which will have to be used by a researcher when he or she is proceeding with a systematic research, expecting an award of degree, or maybe expecting, it may be that you really expect a specified outcome. Outcome or implication for your research. So that talks about the well accepted format of conducting research to arrive at conclusions. So that's why it is called as formal designs. Informal, maybe that is acceptable, but when we are going with outputs or implications which need acceptance on a wider range, which needs acceptance on a wider range to make some alterations in our existing system, then we have to see that we are going with a formal design. That's why I always suggest that when you go with your PG projects, when you go with your MPhil projects, or even your PhD thesis, please remember that some of these designs would be suitable for you because that is acceptable. In over the years, people have realized the importance of such models, such designs. They've already proved that these designs are working with respect to social science. So that is why we discuss that with greater importance. Okay. So the first one is completely randomized design. Okay, what we are going to do. There are broadly, as you can see in front of you, there are broadly 4 categories of formal. Of course, there are variations. There are n number of alterations to these basic models. There are. If you look into the literature, if you look into the available theory, you can find that there are n number of designs, but the basic evolution of that design might be from one of these categories. The basic structure of that design would have been from one of these designs. That's why we say that formal designs can broadly be categorized into 4. One is completely randomized design. Second one is randomized block design, Latin square design, and factorial design. Now, I want you to remember the concepts which we have learned when we were discussing our experimental designs. The first one is principle of replication, where we discussed that in order to minimize the effect of extraneous variables, in order to predict the outcome near to the reality, the same experiment is repeated more than once and ensuring that you get the same result. With the same sample, with the same environment, you're repeating it more than once. So that is why you call that as principle of replication. So that is every experiment in social science research, a good research design should be supporting the principle of replication. That's the first clause. Okay. Then principle of randomization. Suppose if I have a population with 100 units in that, principle of randomization say that every unit, each in this 100 units have equal possibility of being picked and allocated into different experiments, different treatments. So that's called as the chance factor. I'm not manipulating or I'm not purposefully eliminating some units from the population. That means the research is biased. So in order to avoid that, what we say is principle of randomization. Chance factor. Any unit from your population has equal chance of being picked up for the study. Then principle of local control means we are trying to bring the impact of extraneous factor into our study as far as possible by dividing the groups into various homogeneous category. So today we are going to detail in with respect to what is local control with respect to randomized block design, all that. So local control, see, suppose if I have a population with heterogeneous features, what I'm trying to do first would be, I'm trying to categorize that on the basis of some homogeneous character. And within the group, every member has equal chance of being picked up. So maybe I have a population with many homogeneous groups. I have divided that based on some feature which will help me to eliminate the variability caused due to extraneous factor. Now we were discussing that extraneous factors are those factors which are not part of this particular study which we are into, but we know that they have some kind of impact on our study. But fortunately or unfortunately, we may not be covering that because of the vastness or depth of our study, and maybe because of the scope of the study which we have selected. So that is why when we are talking about principle of local control, we try to eliminate the variability caused by the extraneous factors. Now, how do we do? Normally, what we do is we divide the population into different homogeneous groups. Because on a whole, if we look, maybe our population is totally heterogeneous. The units in the populations are heterogeneous. But we try to categorize that on some basis which are suitable to our study. And each categorization which will be a homogeneous group. So there is a local control, right? From that, we have every possibility of fixing or picking different units. So that is what we call as principle of local control. So these three principles are equally applicable in all the formal designs. In fact, if all of our formal designs will be evaluated on the basis of how far that design is addressing the principle of replication, principle of randomization, and principle of local control. How well that design is addressing these three aspects. That's why when we design for our project, when we design a research design for our particular study, area of study, we really have to remember that if possible, we will have to incorporate these three aspects into our study. The experiment should be repeated more than once to ensure that you are getting the same result. There should be principle of randomization, which is applied at the time of choosing of sample from our population. Of course, if we have a total heterogeneous group, say for example, if you take the student community, and if you are looking at the impact of training, okay, on a particular student community, you know that the impact of training, one factor would be the quality of the training, right, or the quality of the trainer, and another is IQ level of the student. Maybe we are not including that as our independent variable. So we have to remember that I have to nullify the impact of these as we said, two extraneous variables. I have to eliminate it or reduce the impact so that my result will not vary from group to group. Because maybe training will be very effective with a group with high level of IQ, maybe not that effective with a low level of IQ. Chances can be, no, but so in that case, I will have to form a homogeneous group. When I look at the student community, it's a heterogeneous group with respect to IQ. So what I will do is I will apply some kind of local control, categorize the student community into different groups based on their IQ level. So that's actually a homogeneous categorization, and pick at random from these groups. Every student in each group have equal possibility of being selected for our study. So naturally, I am eliminating the difference due to variability in IQ. At the same time, I'm applying the principle of randomization. So that's what we say. These principles should be applicable with respect to experimental designs. It should be applicable to all designs what we are discussing today in our class. Now going back to what we are into. So what diagrammatic representation will be easy for you to understand. Before I talk about a theory, it will be easy for you to understand if I show the diagrammatic expression. So in case of completely randomized design or CR design, it is in the one which is exhibited before you is a two group simple design. Okay, you have an experimental group and a control group. Okay, now what you have to remember is, see, the same example which I was talking about. You are testing at the effectiveness of the training. Okay, and you are the population for you would be the student community, randomly selecting the sample from the group. So we are applying the principle of randomization. Okay, and the sample at random being assigned to different groups. We are assigning that to different groups. One is control group, another one is the test group or experimental group. And what we are going to do is we are giving the treatment. One training, either you can go in that way, training is given to one group and the other group is left free, or we can do that training is offered to two types of trainings, like one might be personality training and the other would be soft skill training, which is offered to two groups. And then you are looking at the effectiveness of those training in the selected group. So here what we have to remember is principle of randomization is applied. Simply you are selecting the sample from your unit and you are allocating into two different groups. So our students, see, I maybe in our class, simply I select 5 from you and allocate to the experimental group, and another 5 given to the control group. And I'm just checking at how effective is this training. Maybe I'm offering the same kind of training to the two groups and I'm just checking how effective is it. Maybe depending on what is my design. Suppose if I want to exclusively look into which training is good, I might offer two trainings to both the groups and just look at the result. So here what we have to remember is it's a simple design. You don't have any complications. But the problem with the design is we know that there are two things that can affect the result of the training. As I said at the beginning, it can be the IQ level of the students, or it can be the ability of the trainer. Suppose if a person is very good in training, he's been experienced for many years, and if that particular person is offered to experimental group, maybe the result would be better as we compare with the control group. So there are two extraneous factors which we have not compared here, which we have not considered here, which makes this design little handicap. There can be the effect. So when I'm saying that, yes, this model is good for looking at the effectiveness of training, then people can question me with, okay, what about the IQ level of the students? You have not considered that in this design. What about the ability of the trainer? You have not considered that in this design. Maybe for simple study, preliminary study, this design is okay. But if I'm trying to build a model which could be used for for deciding about the quality of a training for my organization, or maybe for the governmental projects, I might be questioned with all these. That led to the development of something called as randomized replication design. Okay, randomized replication design. Here you can see that there is repeated, here there is no principle of replication. You are just checking it once, you are arriving at the result. When this particular model, when we actually convert that using the principle of replication, we say that there is principle of randomization, there is principle of replication applicable in random replication model. Now, how does this happen here is, in our case, there were two extraneous factors which we identified. That is, we identified with respect to, one is the IQ level of the student, two is, we talked about the training quality of the trainer, the quality of the trainer. Right. So here in this, what we did is we tried to bring the principle of replication. Now, how do we do that? Just listen to me very carefully. See, the population applicable for our study, which is allowable for our study. See, in this case, we said the example of student community. Now, there is random selection of students, sample to be studied, and there is random assignment of them to different groups. I have many groups, not one group. I have group 1, group 2, group 3, group 4. So principle of repetition will come. Same as the case, I have group 5, group 6, group 7, group 8. Again, the replication comes. Here also I have the experimental group and control group. But I do not have one each, I have many. So I'm repeating it again and again to ensure that the result I get is good. right? Same as the case, we had one problem with the quality of the, so student community, IQ level, the extraneous variable being taken care by having repetitions into different groups. Now we, another extraneous variable we said which might be having an impact is the quality of the trainer, right? There also we are applying the principle of replication. Why? Here I have a group of trainers, okay, available to conduct the treatment. From that, what I will do is I select them, randomly assign to different groups, maybe the experimental groups and control group. So I am doing it again and again. Every trainer might be going for group 1, group 2, group 3 and group 4. Same as the case, the trainers here also might be going for group 5, group 6, group 7 and group 8. Or maybe at random I'm allocating that to different group. So the ability of the trainer may not be, or I'm trying to minimize, there can be some impact, but I'm trying to minimize the impact of the extraneous variable called the ability of the trainer in this particular experiment. So such experiment where the principle of replication along with randomization, when principle of replication is applicable, we call that as completely randomized design with random replication design. Okay, CR design with random replication design. I repeat, in this case, we can see that there was no possibility, in this design, there was no possibility of replication. Accordingly, the principle of replication was not, the principle of repeated experiments were not applicable. So we were not sure whether the result of the study will be repeated or not. Also, there were the impact of two extraneous factors which were not part of our study, which was very evident. One is the IQ level of the student, two is the trainer, the quality of the trainer. In the said experiment, okay, you can have n number of experiments like that. Say, for example, if I take the example of what is a possibility of a person getting infected after vaccination of COVID-19 disease. That's an experiment. So I can select those people who went with the COVID vaccination and the possibility of getting affected by or getting infected by the by that particular disease. I can look into. So at random, I'm just allocating them into different groups, and then I'm just trying people with who are given with vaccination and the occurrence of the disease, people who were not given with vaccination and the occurrence of disease. But we know that there are many extraneous factors if we look into that experiment. So in order to bring some kind of meaningful, in fact, many of the government, they went with including the World Health Organization, they went with conducting such experiment using more or less as we say, this random replication design across different nations, because we know that there are many factors that can affect the occurrence of the disease after vaccination. It can be your health status, it can be the conditions to which you are exposed to. If you're a health worker, the possibility is more. If you're a diabetes patient, it's been said that the possibility is more. If you are a person above the age of 50, the possibility is more. So all these are extraneous factors which I may be considering for which I know that there is an impact, but just to minimize the complication, what I go with principle of replication. But here also, in this design, it's not shown, but if I really want to have some kind of control, what I can do is to bring some clarity to my result, I can create different randomized groups, homogeneous group, like diabetes patients, one group, homogeneous group, people above 50 years, one homogeneous group, people, health workers, one homogeneous group. So I can pick sample from each of it at random, which means I'm applying the principle of local control. It's not shown in this experiment. I'm just expanding it for you to understand the scope of it. Okay, so that's what we mean by principle of local control. So this is all about completely randomized design with random replication. So